Hello guys, welcome to another video. So in this question, if you see that they have given the three statements and they have asked us to find out the right one. So if you see the equation of PQ plot, P will be equal to sigma 1 plus sigma 2 divided by 2. Yes, sorry, sigma 3. Okay, sigma 3 divided by 2. And Q will be equal to sigma 1 minus sigma 3 divided by 2. Okay. So if sigma 1 is equal to sigma 1 equal to sigma 3, then Q will be equal to 0, where P does not equals to 0. So if you see the point 1, the stress point lies at the origin of the PQ plot is false. Okay. The stress point lies on the P axis of the PQ plot. Yes, because P is not equal to 0. Okay. And Q is equal to 0. Right. Next, if sigma 1 greater than sigma 3, then P not equal to 0, Q not equal to 0. Therefore, both the stress points P and Q are positive. Yes, then that is also true. So P false, Q true, and R also true. Option A is the right answer. In this question, they have given that a conventional drain triaxial compression test was conducted on a normally consolidated clay sample under effective confining pressure of 200 kilopascal. Okay, so we'll write down the given data. They have given the effective company for first specimen. They have given the effective confining pressure sigma 3 dash is equal to 200 kilopascal. The deviator stress at failure was found to be 400. Okay, deviator stress was 400. So sigma d will be 400 kilopascal. An identical specimen of the same clay sample. So it is sample 2, which is consolidated to a confining pressure of 200 kilopascal. So for second specimen, they have given the confining pressure as 200 kilopascal and subjected to a standard undrained triaxial compression test if the deviator stress is at failure in 150 kilopascal. So the deviator stress will be 150 kilopascal, and they have asked us to find out the pore pressure developed. Asked us to find out the pore pressure developed. So for first sample, we can get the total triaxial stress, which will be equal to effective triaxial stress will be equal to sigma 3 dash plus sigma d, which is 200 plus 400, that is 600 kilopascal. So for second one, it will be equal to, we can get the total triaxial pressure, total triaxial stress. Sigma 1 is equal to sigma 3 plus sigma d, which is 200 plus 150, 300 kilopascal. So from the second specimen, we can get the effective confining pressure sigma 3, which will be equal to sigma 3 minus u. That is sigma 3, it is 200 minus u, and sigma 1 dash will be equal to sigma 1 minus u, that is 350 minus u. Okay, so if you see the stress relationship, you get sigma 1 dash will be equal to sigma 3 dash tan square 45 plus pi by 2 plus OC tan 45 plus pi by 2. So from the first specimen, we can take the value. Then the test which is conducted is in drained triaxial compression test. So C will be equal to 0. So if you substitute the value of the first specimen, that is 600 equal to sigma 3 will be 200. 200 tan square 45 plus pi by 2. For both the specimens, C will be equal to 0 since the test is triaxial and train triaxial compression stress. Okay. By solving this, we get pi s 30 degree. And for the second specimen, this one is for the first. Okay. For second specimen, it will be sigma 1 dash. Since we have considered C as 0, we can directly write sigma 3 dash tan square 45 plus pi by 2. Okay. So sigma 1, which is nothing but 350 minus u. Sigma 3, it is 200 minus u tan square 45 plus the value of pi we have found as 30. So 30 by 2. By solving this, we get u equal to 125 kilopascal. In this question, they are given that the total horizontal and vertical stresses at point X in a saturated sandy medium are 170 kilopascal and 300 kilopascal. Okay, so we'll write down the given point. So total horizontal sigma h will be 170 kilopascal. Total vertical sigma v will be 300 kilopascal. The static pore water pressure is, that is, u is equal to 30 kilopascal. At failure, the excess pore water pressure is measured as, so the excess pore water pressure will be 94.5 kilopascal. And the shear stress on the vertical and horizontal planes passing through the point x are 0. Okay, so shear stress they have given as the 0, right? Then the effective cohesion is 0 kilopascal, which is C is equal to 0, and effective angle of internal friction phi is equal to 36 degree. They are asking us to find out the shear strength. Okay. So the normal stress, the equation of normal stress will be equal to sigma n, that is equal to sigma v plus sigma h divided by 2 plus sigma v minus sigma h divided by 2 cos 2 alpha. So the value of alpha can be found out. Alpha will be equal to 45 degree plus pi by 2, which is nothing but 45 plus 36 by 2, which is 63 degree. Okay. So from this we can calculate the normal stress sigma n. Sigma n will be equal to sigma v, that is 300 plus 170 divided by 2 plus 300 minus 170 divided by 2 cos 2 into 63. Okay. With this we can get sigma n will be equal to 196.797 kilopascal. So now they are given the static pore pressure and excess pore pressure. So you keep this as static pore pressure. So the overall pore pressure will be equal to U will be equal to static pore pressure plus excess pore pressure. Therefore, U will be equal to 30 plus excess pore pressure will be 94.54. 94.54, which is 124.54 kilopascal. Right. So the normal stress, which is given by 196.79, and the effective stress sigma n dash will be equal to sigma n minus u. That is 196.797 minus 124.54, which is nothing but 72.297 kilopascal. So with this, we can calculate the shear strength. Shear strength tau F will be C plus sigma n tan pi. Sigma n dash tan pi. Tau F will be C is nothing but 0. 0 plus sigma n dash 72.297 tan pi will be equal to 36. So tau F will be 52.524 kilopascal. They asked us to find out up to 2 decimal places. So you take tau F will be 52.52 kilopascal. Okay. In this question, they have given that in a drain triaxial compression test, a sample of sand fails at deviated stress, which is deviated stress they have given of 150 kilopascal. Deviated stress of 150 kilopascal under confining pressure of 50 kilopascal. The angle of internal friction of the sample. Since the sample is sand, it will have no cohesive forces, so C will be equal to 0. Okay. So they have given the deviatoric stress sigma D, which is 150 kilopascal, and they have given the confining pressure sigma 3, it is 50 kilopascal. So from the stress relationship, we can get sigma 1 is equal to sigma 3 tan square 45 plus pi by 2 plus 2c tan 45 plus pi by 2. So here c is equal to 0. So we can neglect the second part of the equation. Okay. So sigma 1 will be equal to sigma 3 plus sigma d, which is nothing but 150 plus 50, that is 200 kilopascal. Okay. So 200 will be equal to 50 tan square 45 plus pi by 2. Okay. By solving this, we get pi will be equal to 36.872 degrees. So by taking it to the nearest integer, we'll get pi will be equal to 37 degrees. For this question, if you draw the stress bar diagram, we can find out the answer. So we'll draw stress bar diagram for OS. Okay. So we'll draw for OS. So it is nothing but left side will be sigma 3 and right side will be sigma 1. So for OS, it is projecting in left side direction. So here it will be sigma 1. So this one will be sigma 3 dash, sigma 3 double dash. So for OS, it is projecting in the left side direction, where sigma 3 it is increasing and sigma 1 it is constant. So sigma 3 it is increasing, sigma 1 it is constant. So OS is option 4. So for OR we will draw for OR. So for OR will be nothing but it is increasing, where sigma 3 sigma 1 is increasing. So for OR, sigma 1 is increasing. This one is sigma 1. Sorry, left side will be equal to sigma 3, sigma 1, sigma 1 dash, sigma 1 double dash. Sigma 1 is increasing and sigma 3 is constant. For OR, sigma 1 is increasing, sigma 3 is constant. Okay. So for OP, we will draw for OP. For OP, it is in downward direction, which is nothing but the decreasing of sigma 3. So OP will be like this. This is for OP. So it is sigma 1, sigma 3 dash, sigma 3 double dash. So sigma 3 is decreasing and sigma 1 is constant. Sigma 3 it is decreasing and sigma 1 is constant. Sigma 3 decreasing, sigma 1 is constant. That is for OP. So the rest option will be OQ. So OS, which is 4. Yes, you have the option C and D, where OR it is 1. So option C is the right answer. In this question, they have given the graph of volumetric strain versus shear strain. So if you see the both graph, for curve P, shear strain it is increasing. For curve P, shear strain it is increasing, and with respect to volumetric strain, which is also increasing. But for curve Q, shear strain is increasing, but volumetric strain is decreasing, which is in the negative direction. So from this we can know that curve P represents the dense sand and over-consolidated clay, where curve Q, which represents the loose sand and normal consolidated clay. Yes, option A is the right answer. The most appropriate traction test to assess the long-term stability of excavated clay is nothing but consolidated drain test.